Hello students, welcome again to our new lesson today in year 10 chemistry. My name is Mr. Situma. Now, our subsection of discussion today, our subtopic of discussion is on metal hydroxides. Metal hydroxides. If you remember, in our last lesson we did carry out a practical on the precipitation of the different metal ions from the solutions, and we used sodium hydroxide. We carried out experiments on solutions containing metal ions which are colorless in solution, and also we used colored solutions with the metal ions that form specific colors. We were able to get the observations. Now today we want to discuss the results of that particular experiment so that we can be able to identify in each case which particular type of precipitate was being formed and the name of that precipitate, and any other further treatment, chemical treatments that was done or was to be done to any of the precipitates formed. Now the objective of the lesson today is that at the end of it all, we should be in a position to explain the observations made when the precipitates are formed from sodium hydroxide. We should be in a position to explain the observations made when the precipitates are formed from sodium hydroxide. Now remember that questions on practical aspects can either occur in a practical exam or they can also come in a theory exam but carrying a practical question. So don't forget that they don't only occur in the practical exams, they can also occur in the theory exam, and therefore in each particular practical set that we have, you need to be very careful to maintain the observations and be able to carry out the correct conclusions in each particular case. Now, metal hydroxides are formed when solutions containing the metal ions react with the sodium hydroxide. Metal hydroxides are formed when the solutions that contain the metal ions react with the sodium hydroxide. That means that the precipitates that we were seeing, observing in our previous lesson, are actually metal hydroxides of the respective metals with the sodium hydroxide. That means we have zinc ions, we have zinc hydroxide, we have lead, and so on and so forth. So basically, the metal hydroxides come about because the metal ion combines with the hydroxide ion from the base. That is when the metal hydroxide is formed and comes out as a precipitate. For example, when sodium hydroxide is added into a solution or a small amount that contain zinc ions, there will be formation of a white precipitate. When the sodium hydroxide is used and added to a small amount of solution containing the zinc ions, then there will be formation of a white precipitate. That was actually what we observed from our previous experiment. Remember that most of the solutions which had colorless, formed white precipitates. Then the colored solutions formed precipitates corresponding to their colors. But the colorless ones, all of them were forming white precipitates. So in this case, for zinc with the sodium hydroxide, the white precipitate formed is zinc hydroxide. That white precipitate that was formed is zinc hydroxide. Now remember that in this particular reaction, in the definition of the word precipitate, we say it is a solid formed when two solutions are brought together. So in this particular case, we have a solution of sodium hydroxide and we also have a solution of zinc ions. These are two colorless solutions which are coming together. So when the ions inside the solution combine and they form the white precipitate, if you filter out the liquid inside the test tube, then you will remain with a solid that is white in nature. A white colored solid will be remaining. So if in the exam, an examiner tells you that sodium hydroxide reacts with a solution containing zinc ions to form solid X, then that solid X is another term for precipitate X, because the definition of a precipitate is a solid that separates out when two solutions react. So that's exactly what the point I wanted to drive home, that you may not necessarily maybe get the examiner talking about the precipitate. They also talk about solids. A solid is formed. They may also ask you to give the color of the solid formed. The color of the solid formed. That means the color of the precipitate that is formed in this kind of reaction. Now, when we added excess of sodium hydroxide to the same test tube that was containing the zinc hydroxide precipitate, we discovered that the precipitate actually dissolved, forming a colorless solution. When we did add excess of the sodium hydroxide to the very test tube in which the white precipitate of zinc hydroxide had been formed, then the precipitate was able to dissolve. Now, maybe just mention something small about the excess. When you're adding the excess, you have to add until there is no further change. Now, sometimes if you add and you discover that the precipitate is persistent, you shake a little bit so that you can be able to identify if actually the precipitate will dissolve or not. The colorless solution formed is known as sodium zincate. We refer to it as sodium zincate. Now, sodium zincate is a salt. This is a salt. Why? Because we have a reaction involving zinc hydroxide and sodium hydroxide. And if you still remember, in our discussions, much in our earlier lessons, we talked about amphoteric oxides and hydroxides. Amphoteric oxides and hydroxides. One of them was zinc oxide and zinc hydroxide. So when this zinc hydroxide reacts with the sodium hydroxide, the zinc hydroxide will be reacting as an acid. That means it's reacting with a base, so it will be acting as an acid, and then in an acid-base reaction, obviously we have formation of salt and water. So the sodium zincate formed is the salt that comes from that particular reaction. That is basically the reaction that takes place. We have, for example, zinc sulfate, remember, is a soluble salt, and combining with the sodium hydroxide results to formation of sodium sulfate and zinc hydroxide. This zinc hydroxide formed is a gelatinous white precipitate. It is a white precipitate, and then when you add excess of sodium hydroxide, the same white precipitate that was formed in stage 1, excess of it all, you form the sodium zincate. That is the formula for sodium zincate, which is a solution that is colorless. So that is exactly what we mean by the sodium zincate. Now, lead 2 ions also react with the sodium hydroxide, resulting to formation of a white precipitate, which is known as lead 2 hydroxide. At least by now, you should be in a position to identify the name of the precipitates formed. Because if you look at the pattern of the precipitates, you'll discover that the metal ion picks up the hydroxide ion from the base. When the two combine, they form a metal hydroxide, which is the precipitate. So for the zinc, for the lead to ions, it reacts with sodium hydroxide to form a white precipitate, which is lead to hydroxide. Lead to hydroxide. Now, when we add excess of the sodium hydroxide to the same white precipitate, then this particular precipitate dissolves. When you add excess of this, the precipitate dissolves, and when it dissolves, it forms a colorless solution. This colorless solution is the one that we refer to as sodium plumbate. Sodium plumbate. That is the salt that is formed from that particular reaction, which means that the lead to hydroxide is also an amphoteric substance reacting with the base. Let's continue discussing more of these particular precipitates in our second part of our discussion. See you then.